right, we're going over the Chapter 3 review on page 80. What we're going to do is talk about the rules and the definitions and follow the rules and definitions. So number 1, it says the ratio of commission to sales on a certain newspaper is 15 cents to $1. Write this ratio in simplest form. As it says ratio, what's the first thing that goes through our mind? The definition, which says that a ratio is a comparison to items. And then what goes through our mind next? Rule 1, 2, 3. What's rule 1 of ratios? Whatever is said first goes first. It says write this ratio and it's commission to sales. So what do we write on our paper first? Commission to sales. The commission was 15 cents. If we write that as dollars, it's 0.15 to $1, which is 1.00. So we satisfied the definition and we satisfied rule 1. Whatever it said first goes first. Now rule 2 says that a ratio has to be whole number to whole number. You cannot have a decimal in a ratio. To make it not a decimal, we shift it to. What would we have to multiply by to make that happen? 100. Whatever you do to one member of the ratio, you have to also do to the other member of the ratio to keep it in the same ratio. So that gives us 15 to 100. Rule 3 of ratios says you must simplify each ratio by dividing by the greatest common factor, which is 5. So we divide by 5, and we get 3 to 20. And again, we know we're right. There's no doubt that we're right because we said the definition, and we said all the rules, and we followed all the rules. And in mathematics, if you follow the rules, you're right every single time. People take a test and say, I think I did pretty good. I'm say, why do you think you did pretty good? I just felt good about it. You probably failed, right? Either you know you did good or you don't in math. There's not any in between. Either you know you did good on the test or you're not sure. And if you're not sure, probably made some mistakes, right? Okay. Any questions on number 1? Also, we might say that all these rules we just quoted are on page 51. So if you couldn't say them, that's where you go to study, page 51. All right, question number 2. The angles of a triangle, a ratio of 2 to 3 to 4, find the measure of each angle. What are we going to do first, and how did we know to do it? We write characters, somebody said. And how did we know to write characters? It's a formula word, somebody said. Good. We need to write characters because there's a word sentence. And we know what word sentences can be. Page 40, right? They could be A comparison between two characters. B, formula words like perimeter, area, volume, circumference, etc. And what did we add? We've added how many formulas from chapter 3 to our formula word list on page 40? 7. Complementary, supplementary, sum of the angles of a triangle is 180. That's on page 52. Part equal percent times whole. New price equal original plus increase. New price equal original minus decrease. That gets us to 6. Those are on page 62. And then average, which is on page 66. So there's 7 new formula words we added from chapter 3. Those have to be in your brain, right? All right. And so which one of those did we find that we're going to put on our word sentence line? Angles of a triangle. One of the things that people are going to struggle with on tax is how do you know when you make a word sentence line and put characters and how do you not? So what's the answer to that? What would you tell somebody if they said, how do I know whether to make a word sentence line or not? If you read the paragraph and find an A, B, or C, you're going to make a word sentence line. If you don't find an A, B, or C, you don't. So we got to know what the A, B's, and C's are, right? From page 40. Because if we find one of those, which we have to know from memory, we make a word sentence line. Now, the angles of a triangle, what is it that we know about them on page 52 that was important to us? Their sum is 180 degrees. How many angles is in a triangle? 3. So what's missing from my equation? The angles. So I need to make characters for those missing pieces. Angle sub 1, angle sub 2, angle sub 3. If I were to call them X, Y, Z, how many word sentences would I need? 3. But I don't have enough stuff for 3, so I'm going to have to do something else. Yes, sir. That's a rule on page 52 of the book. There's 3 rules on page 52. It says complementary angles are, how many of the angles though? 2 angles whose measures have the sum of 90. Supplementary angles are 2 angles whose measures have the sum of 180. And the sum of the angles of a triangle is 180. And I could get a piece of paper and show you something here which is interesting. If you were to take the angles of that triangle and cut them off and make a straight line, if I took that angle and put it there, and I took this angle and put it next, and I took that angle and put it last, when you put them side by side, they'd make a semicircle. I could tear the edges of a triangle off and line them up, and you can see that their sum is 180. That's a good visual proof. But anyway, there's a rule that says that on page 180, and that's where it comes from. All right. So we've got 3 unknowns and only 1 word sentence. So page 42, which we have to understand also, says to be able to do the order of operations, you can only have 1 variable or 1 name. If you have more than 1, you must name 1 in terms of the other and use substitution, but we'd have to have a second word sentence from that, which is one of those comparison statements, right? We don't have that. Or what do we do if we can't use substitution? Use special rules to name them in terms of the same variable. There's 4 special rules. The first 3 are on page 42. What's the first 3? Consecutive, consecutive even, consecutive odd. And the 4th one is on page 52, and it is things in a ratio. And rule 4, page 52 says to assign variables. See, we have to go looking for our special rule, right? Consecutive, consecutive even, consecutive odd, things in a ratio. And so what we found was things in a ratio. They're in the ratio of 2 to 3 to 4. How do you assign variables to consecutive integers? Consecutive integers. X, x plus 1, x plus 2. Consecutive odds. X plus 2, x plus 4. That's on page 42, right? How do you assign variables to things in a ratio? You multiply each member of the ratio by x and have only 1 name. Rule 4, page 52. So we're going to have 2 times x, 2x, 3 times x, 3x, 4 times x, 4x. We've only got 1 variable, x, so now we can solve using the order of operations. Understand all that? So, to solve, we're going to use the order of operations, so we're going to do anything we can to simplify, right? Looking for distributive and combining like terms. Can we do the 2 times x to simplify? So we can't do any of those little multiplications, right? That gets us to addition. To add or subtract, what has to be true? Names have to be the same. In algebra, we call them. So we're going to combine like terms and get 9x is equal to 180 degrees. Now we're going to undo multiplication by division, and we get x is equal to 20 degrees. On page 40, the very last thing it says to do, after you solve using the order of operations, you make sure that the answer makes sense to the story. In parentheses it says, read the question again. Because we need to know what we're supposed to answer, right? It could have said find the small one, find the large one, find the median, find x. It said find each one. To find each one, we take what we got for x and plug it back in. That's why I like to write characters and assign variables, because we have a place to plug back in too, right? So we're going to have 2 times 20 degrees is 40 degrees. 3 times 20 degrees, 60 degrees. 4 times 20 degrees, 80 degrees. Any questions on that? That question on the test could be complementary, it could be supplementary, or it could be the sum of the angles of a triangle is 180, right? Page 52 stuff. Any questions on that? All right, number 3. A pesticide mixture calls for 3 gallons of pesticide for every 130 gallons of water. This for every so much of that. What is that? It is a comparison between 2 items. What is a comparison between 2 items? Page 51 says a comparison between 2 items is a ratio. Is this a statement or a question? It's a statement. This is a statement ratio. But that's not the end of the story. It says how many gallons of pesticide would be needed to produce 1,064 gallons of mixture. That's a question, but it's also a comparison of 2 items, which means it's a ratio, a comparison between 2 items. It's a question ratio. Now from experience, I do that all the time, put an N. From experience, we know that we're not going to make characters in a word sentence here. From experience, we know that we're going to solve this one using a, what is 2 comparisons? That's 2 comparisons. You said this is a comparison between 2 items ratio. This is a comparison between 2 items ratio. 2 comparisons of the same 2 items is a proportion. Page 55. 2 comparisons of the same 2 items is a proportion. Now once we know it's a proportion, we learned a drill on page 55, right? We're going to write what 2 words on our paper first? Statement and question. Because we know that we have a statement ratio and we have a question ratio. Each one is a comparison of 2 items, and a proportion is 2 comparisons of 2 items, or, according to the algebra book definition, an equation stating that 2 ratios are equal. Now, what was the statement comparing? Pesticide to water. What was the question comparing? Pesticide to mixture. They're not the same, so it's not a proportion until we make them the same. Do we make them say what the statement says, or do we make them say what the question says? We have to make them say what the question says, and the question was pesticide to mixture. So we're going to put pesticide mixture. Pesticide mixture. What does it say at the top of page 56, which is the page dedicated to mixture proportions? What does it say up there? Sometimes you have to add or subtract to get the parts that you need, right? If there's a mixture, we may have to add the ingredients. Or if it gave us the total in one of the ingredients, you subtract to get the other one, right? Sometimes we have to subtract to get the parts we need, and that's when we're dealing with mixture proportions, which is what we're dealing with here. All right, in the question, how many gallons of pesticide? We don't know. And so we're going to call it P for pesticide. In the question, how much mixture? 1,064. Now, you know how people mess up. We've done it enough to know. You can't be putting parts of the red question, none of those numbers go in the blue statement. You can't be taking questions out of the blue statement and putting it in the red question. You have to put the statement material on the statement side and the question material on the question side. Okay? All right. In the statement, how much pesticide? 3 gallons. In the statement, that's the blue, not the red. In the statement, how much mix? 133. We got to add the ingredients, right? 3 gallons water. Pesticide, thank you. 3 gallons, that'd be some strong stuff. 3 gallons of pesticide, 130 gallons of water. It's a mixture. We add the ingredients and get 133 gallons of mix, right? So the mixture in my statement is the sum of the ingredients, 133. Any questions on that? Processes are important. We've got to be able to say them verbally to be able to do them without an open book test. 1,064 times 3 is 3192. Does that sound good? Good. Is equal to 133p. Now we're going to undo multiplication by division. We divide by 133 and we get p equal. Somebody got a calculator and hit that for us? 24. Thank you. Yes. Yeah. Any questions on number 3? Does everybody see how saying it is so important? So important. You got to say it. It's got to be right there. Click out of your brain. All right. Any questions on the first 3? All right. Everybody got it? Number 4. This would be a good thing to practice for the test, right? This review and the post-pack and the entire book. Number 4. The scale factor of a rectangular room is 2 inches equal 5 feet. If the dimensions of the scale model are 6 inches, then what is the perimeter of the rectangular room? Soon as you see scale, what comes to your mind? Scale model. What else comes to your mind? Similar. If they're not similar, then they're not drawn to scale. If they're drawn to scale, they're similar. It's all based on similarity, yes. 2. 2 inches equal 5 feet. We changed it to a 2 because 1 was too easy, and people would just look at that example and not have to divide at the end. So had to do that. Similar, well, that brings a definition to similar's on page 57. Similar figures. Similar triangles are triangles that are the same shape. So similar rectangles would be rectangles that are the same shape. In similar figures, corresponding angles are equal, but corresponding sides are in proportion. Corresponding sides are in proportion. So how do we find a missing side of similar figures? With proportions. So you need to memorize that if there's a scale, then they're similar, so we're going to deal with proportions. And if we're going to deal with proportions, we're going to have statements and questions. Statement ratio, question ratio. And the statement ratio is my scale factor, right? It says the scale of a rectangular room is 2 inches is 5 feet. That's my statement ratio. If I'm dealing with scale, I'm dealing with similarity. If I'm dealing with similarity, the sides are in proportion. If the sides are in proportion, I'm dealing with a proportion. If I'm dealing with a proportion, then I'm dealing with a statement ratio and a question ratio. And my statement ratio is my given one, which is my scale factor. See how it all goes together. You got to be able to think that if you're going to be a mathematician, right? Not just a math class getter-buyer person. All right. If the dimensions of a scale model are 6 inches by 11, we're going to draw a picture. And the reason we're drawing our picture is so that we can clearly see the question ratio. 11 inches by 6 inches for my scale model. That's symbolic of a big old room that's measured in feet. I'm going to scoot that over a little, even though I don't have room. So I'll have more room. I need to find the length of this thing in feet. Whoops, I put that in the wrong spot. I always make my width this one. I want to find the width of that in feet and the length in feet. Now, I didn't really know that yet, but I'm just drawing a picture. We know the dimensions of the model. We don't know the dimensions of the real thing, right? We don't know the dimensions of the real thing. So we're going to keep reading. It says the scale of a rectangular room is 2 inches equal 5 feet, and all that stuff went through our head. If the dimensions of the scale model is 6 inches by 11 inches, we drew a picture. Then what is the perimeter of the rectangular room? What do we do as soon as we read that last line? Formula word. We put it on a word sentence line. From now till forever, we put A's, B's, and C's on a word sentence line. Even if we're not going to write characters, we're going to make a word sentence line. And we're going to put perimeter on it. And it's talking about perimeter of a rectangle. And so we would look up the formula in our formulas chart and get that the perimeter of a rectangle, 2L plus 2W, is equal to what we're looking for, perimeter. Now we could come over here to the side and make our characters length, width, and perimeter, but we're going to conserve space here. I think we've got that point down. So if we're going to find perimeter, what two things do we have to find first? Length and width. So we're going to have to find the length. I'm writing up here because I need the space. And the width. Now how are we going to find the missing length and width? Well, if we're going to find the missing length and width, what are we dealing with? Scale. If we're dealing with scale, then what's that a part of? Similarity. If they're similar, then the sides are in proportion. So how am I going to find something missing? With a proportion. See how the definitions and rules. People say, I just don't understand this. Either you know it or you don't. Either you can say all those rules, which leads you right to what to do, or you can't say all those rules and you don't know what to do. You understand what I'm saying? You either know it or you don't know it. All right. Well, how are we going to do it? We're going to have a statement ratio and a question ratio. How are we going to do it? Statement ratio, question ratio. Do I make it say what the statement says or what the question says? What is the statement? Inches to feet. It's the scale factor. What's the question? For length. 11 inches. Oops. 11 inches in the model would be how many feet in the real thing? That's the question at hand for length, right? That's my length question. My length question is 11 inches is how many feet, so it's inches to feet. And if my question is inches to feet, then my statement has to also be inches to feet. Understand that? And so now we solve. The question, 11 inches, is how many feet we don't know. Now, what you got to be careful about is if I reverse those. What if I give you the real room and not the scale? You do it exactly the same way, but you don't just go throwing numbers in at random like half of my students will do. You actually write the word inches and the word feet. You know, people that don't write inches, feet, they don't write this inches, feet. They'll set their proportion up, upside down, and backwards because they grab numbers and they put them in like the very last problem they did. And it's upside down and it solves wrong. What'd I do wrong? You didn't write inches and feet. That's what you did. No, that's not where I messed up. I got my numbers wrong. No, you got your numbers wrong because you didn't write the words on your paper, right? If you'd have written the words on your paper and thought, you wouldn't have got your numbers wrong. See? It's all about running the drills. Okay, so the statement. What's the statement? The scale model, the scale factor. 2 inches is 5 feet. So we have a proportion. We cross multiply. L times 2 is 2L. Equal 5 times 11 is 55. We're now going to undo multiplication by division. And we get that the length is 27.5. Let's see how we got that. Now with a width. What's the question? Width. 6 inches is how many feet, right? The question is 6 inches is how many feet, and so my question ratio is inches to feet. If my question is inches to feet, my statement has to be inches to feet because a proportion has to be what? What's the definition? Two comparisons of the same two items have the same thing on top both times and the same thing on bottom both times. Definition of a proportion. All right. In the question, how many inches? 6. In the question, how many feet? We don't know. We call it W. If you don't go through this process, you're going to write some numbers upside down sooner or later. In the statement, what is the statement? It's the scale model, right? The scale factor. It's a scale factor, right? Yep. So how many inches in the scale? 2. How many feet in the scale? 5. Everybody see how we set that up. So to solve a proportion, you cross multiply. W times 2 is 2W is equal to 5 times 6 is 30. We're going to undo multiplication by division, so we divide by 2, and we get the width is 15. After you solve using the order of operations, what do you do last every single time according to page 40, number 6? You read the question again, to make sure that the answer made sense to the story. The question is, what is the perimeter? We hadn't answered that yet. We'll know that if we'll read the question again. So we're going to plug them in, right? We got the length is 27 and a half. We got the width is 15. We plug them in. We get 2 times the length, which is 27.5 feet, plus 2 times the width, which is 15 feet, and that should give us our perimeter P. We simplify the left using the order of operations. We're going to multiply first. 2 times 27 and a half feet is 55 feet. 2 times 15 feet is 30 feet. When you add or subtract, the name stays the same. And the name has to be the same. So we're going to add feet to feet and get feet, right? 55 feet plus 30 feet is 85 feet for the perimeter. Any questions on that? You will find an example of this. We begin proportions on page 57. At the bottom of page 57, we have similar triangles, which we had the definition of similar. And then on the top of page 57, in fact, the whole entire page 57A is dedicated to scale models. So we find out how to do this problem on page 57 and 57A in the text. Any questions on number 4? Okay. Number 5. Number 5 is found on page 58 at the top. There's 2 examples. One of them's got some signs in it. The top right one, I think it's number 10 and 11 on page 58, but you need to be ready to deal with your signs. This is a what? How'd you know it's a proportion? It's 2 comparisons of the same 2 items. That really fits a word problem, right? What's the real algebra definition of a proportion? An equation stating that 2 ratios are equal. That's the algebra book definition, right? An equation stating that 2 ratios are equal. So the algebra book definition fits these algebraic ones, and 2 comparisons of the same 2 items, the one I made up fits the word problems. Now I made that one up so that in a word problem you could see what to do. All right. How do you solve a proportion? You cross multiply. It's called the product of the means and the product of the extremes. Somebody quote that. Rule 2, page 37. You got to use it to do this. If you multiply something to or divide something by, a sum or difference. If you multiply something to or divide something by a sum or difference, you have to take that sum or difference and put it in parentheses. Now, we summarize this on page 171. Page 171 is distributive properties summed up, which basically says you can only distribute onto a one lesser operation. So that's where we kind of go and say, okay, it's multiplication onto addition, that's one lesser, so we got to put in parentheses and distribute. So we're going to have 6 times 2x plus 4. We have times a sum, so we put that sum in parentheses, and we're going to distribute the 6. Now, as if we didn't already know to distribute, we would use the order of operations on page 33 to solve. And it says we're going to do anything we can, that's 33, in the order, please excuse my adherent Sally, to simplify each side down. And when we get to multiplication and division, it says to look for distributive. And when you get to addition and subtraction, you look for combining like terms. It says that on page 33, right? So we would even be looking for distributive if we hadn't already quoted Rule 2, page 37. So we're going to distribute. We're going to get 3x plus 24 equal 12x plus 24. And there was a negative 4 that we lost right there. Thank you. Watch those little signs. And so when we multiply with different signs, right here we get a negative 24. And you know that I usually don't put a negative, right? Just to be consistent, we call it a minus for negative. Thank you. Understand that? Now, when you've done all that you can do to simplify the left and right, what's next on the order of operations horseshoe on page 33 at the bottom? Good, it's at the bottom. Excellent. You're going to get the variable that you're isolating. That's actually a 12. I tried to cut the 1 off. Sorry. We're going to get the variable that we're isolating, x, on one side of the equal sign, remembering to change the sign when you cross over. That's using what property when you change the sign? Additive inverse, page 29 in the middle of the page. So we got 3x minus 12x. What's 3x minus 12x? Negative 9x. You subtract and take the larger sign, right? What page your sign rules on? Page 18 for those that don't know their sign rules. When you add or subtract with different signs, subtract the larger sign. So we get negative 9x plus 24 is equal to, don't lose that sign again, negative 24. So we did all we could do to simplify by distributing. We got the variable we were isolating on one side of the equal sign, remembering to change the sign when you cross over. Now it is time to undo. We've got multiplication and addition. Which one do you undo first? Addition, because you reverse the order of operations. So we're going to subtract 24. We get negative 9x equal. The signs are the same, so you add and take the common sign. When you add or subtract with the same sign, you add and take the common sign. Page 18, sign rules. Now we're going to undo multiplication by division, and we can leave it improper. When you divide with the same sign, the answer is positive 48 ninths. Any questions on that? See you tomorrow. We'll pick up from there tomorrow.